In January 2005, NASA launched a unique space probe. Its mission was to answer a simple cosmic question. Where did Earth's water come from? The probe, called Deep Impact, traveled 270 million kilometers, closed in on a comet, and inside that comet were secrets humanity had chased for centuries. Across the entire universe, there seems to be only one place where humans can live: Earth. Sometimes it feels as if our planet was built for us, with everything life needs: water, food, oxygen. In this vast and endless cosmos, there may be other worlds like ours. But for now, Earth is the only one we know where humans can survive without help. Yet 5 billion years ago, Earth didn't even exist. Today's solar system sits on the edge of the Milky Way. Before our planet was born, this region held a massive cloud, a cloud made of dust and gas. What happened inside that cloud that turned it into a planet, the planet we call home? Astronomers call that dust and gas cloud a molecular cloud. It was filled with microscopic grains, sand, silicon, and specks of many metals. It formed from the ashes of dead stars, ancient suns that burned all their fuel and exploded, scattering their elements across space. These clouds don't look like the fluffy ones in our sky. They're strange, ghostly, captured in breathtaking images by the Hubble Space Telescope. Incredibly, this single cloud was 100 light years across. If a beam of light started at one edge, it would take a century to reach the other. To put it simply, this dust cloud was about 6 million times the distance between the Sun and Earth. From clouds like these, new stars and planets take shape. And the force that sculpts them is gravity. Gravity isn't something that exists in space as a substance. It's the pull objects exert because they have mass. The more massive the object, the stronger its gravity. In the molecular cloud, tiny particles began sticking together under gravity. Bigger clumps pulled in smaller ones. Collisions became frequent, violent, releasing energy. The spinning cloud warmed up at its center. For millions of years, the core grew larger, spun faster, and got hotter, until, at last, it ignited into a giant fireball, our Sun. The leftover cloud, dust and gas, kept orbiting the Sun. From those leftovers would come the planets, their moons, and eventually, life. The first hypothesis about this process, how a star forms from a cloud, was proposed in the 1700s by German philosopher Immanuel Kant and French scholar Pierre-Simon Laplace. At the time, it was just an idea. From the